Hi, my name is Patrick Reagan. Welcome to Basic Networking Hardware, Part 5, NAS and SAN, where we discuss Network Attached Storage, or NAS, and Storage Area Network, or SAN. A storage area network, or SAN, uses block-level access. When a computer such as a server connects to the SAN, it looks and feels like a local storage device. Since it requires a lot of bandwidth, it is best to use an isolated network with high-speed network technologies. A network-attached storage, or NAS device, is a single box connected to a network that contains multiple hard drives, allowing access for multiple computers. It provides file-level access. When computers access a NAS, it uses standard network file sharing protocols such as NFS or SMB. Network-attached storage, or NAS, is a file storage device that connects to a network, allowing multiple users and heterogeneous client devices to retrieve data from a centralized disk capacity. NAS systems are network appliances containing one or more storage drives, often arranged into a logical, redundant storage containers or RAID arrays. RAID, short for Redundant Array of Independent Disks, can provide faster performance and possibly fault tolerance if a disk goes bad within the array. Key features include the following. It provides a central location for storing data that can be easily accessed by multiple devices on the network, which is ideal for sharing files such as documents, images, videos, and backups among multiple users. It provides file-based storage, means they store data in a hierarchy structure of files and folders. Common file sharing protocols include NFS, Network File System for Unix and Linux systems, and SMB/CIFS, Server Message Block, Common Internet File System for Windows systems. Basically, a NAS is a dedicated file server. NAS usually connects to a local area network, or LAN, via Ethernet, allowing users to access it over the network, which can be accessed by various devices, including computers, tablets, smartphones, and IoT devices. NAS devices are generally easy to set up and manage, often with a user-friendly web interface. NAS are suitable for both home users and businesses. Many NAS systems support RAID configurations, which provide data redundancy and protection against disk failures. Some models offer advanced features like snapshots, replication, and data deduplication. Some models can be scaled by adding more drives or expanding capacity as storage needs grow. Some enterprise-level NAS solutions offer clustering capabilities for higher scalability and performance. A storage area network, or SAN, is a high-speed network that connects and provides shared access to consolidated pools of storage devices. SANs use a separate dedicated network infrastructure to provide high-speed data transfer between storage devices and servers. This separation from the main LAN ensures better performance and reduces traffic congestion. Unlike NAS, which provides file-level storage, SANs provides block-level storage, which means data is stored in blocks, which the operating system treats as individual disks. This approach is ideal for applications requiring high performance, such as databases and virtualization. SANs usually have dual power supplies and higher levels of RAID, such as RAID 10 with spare drives. SANs are designed for high performance with low latency and high throughput. A SAN uses specialized switches designed to handle high-speed data traffic between storage devices and servers. These switches are optimized for performance, reliability, and scalability in data storage environments. By decoupling storage from individual servers, SANs optimize storage utilization and ensures that critical applications have the reliable, fast access to data they require. The SAN switches use one of the following. Fiber channel, or FC switches, offers high-speed performance, typically offering speeds of 8 gigabits per second, 16 gigabits per second, 32 gigabits per second, and 64 gigabits per second, with much longer distances and provides robust zoning features to segment and secure the SAN. iSCSI switches are cost-effective that utilize standard Ethernet infrastructure, making them more affordable and easier to integrate with existing networks with flexible speeds, typically 1 gigabits per second, 10 gigabits per second, 25 gigabits per second, 40 gigabits per second, and 100 gigabits per second. Some Ethernet switches are optimized for iSCSI traffic with features like flow control, jumbo frames, which reduce overhead and increase efficiency, and priority flow control. To maintain a constant connection between a host or physical server and its storage, you should connect the host and storage using multipathing. With multipathing, you can use more than one physical path that transfers data between the host and an external storage device via multiple switches. Internet Small Computer Systems Interface, or iSCSI, is an Internet Protocol-based storage networking standard that enables the transport of block-level storage data over a TCP/IP network. It allows for the creation of storage area networks using existing network infrastructure. iSCSI works at the block level, meaning it communicates directly with storage devices such as hard drives and solid-state drives. iSCSI uses the TCP/IP protocol suite to transport SCSI commands over standard IP networks, including LANs, WANs, and the Internet. Since iSCSI can leverage existing Ethernet infrastructure, it is often more cost-effective than traditional fiber channel SANs, which require specialized hardware. iSCSI uses the following components. The initiator is typically a server that requests storage resources. It can be either software-based or hardware-based. The target is the storage resource that provides storage services to the initiator. It can be a storage array, a server configured as a target, or other network storage devices. The network used for iSCSI is usually an Ethernet network which connects initiators and targets. This can be a standard corporate network or a dedicated storage network. It is recommended to have a dedicated storage network. Fiber channel, or FC, is a high-speed network technology primarily used for storage networking. It provides a reliable and high-performance means of transmitting data between servers and storage devices, making it a cornerstone in many data center environments. Key features of fiber channel include high speed. FC supports high data transfer rates, typically ranging from 1 gigabits per second to 128 gigabits per second, depending on the generation and implementation. Reliability. FC is designed to provide a robust and fault-tolerant network, including redundancy and error detection and correction, to ensure data integrity and availability. Low latency. FC networks are designed to minimize latency, making them ideal for applications that require quick access to data, such as databases and virtualized environments. Dedicated storage network. FC is typically used as a dedicated storage network, separate from regular Ethernet networks. This segregation helps in achieving high performance and reliability without the interference of general network traffic. The following are the fiber channel topologies. Point-to-point, or P2P, is a simple and direct connection between two devices, such as a server and a storage device. Arbitrated loop, or FC-AL, where devices are connected in a loop to share the same bandwidth. While cost-effective, it has the scalability limitations and less commonly used in modern implementation. Switch fabric, or FC-SW, is the most common topology in modern fiber channel networks. Devices connect through fiber channel switches, creating a highly scalable and high-performance network fabric. Components would include host bus adapters, or HBAs, which are interface cards installed in servers to connect them to a fiber channel network. Fiber channel switches are devices that route data between different nodes in a fiber channel network. Storage arrays are storage devices connected to the fiber channel network, providing high-speed data storage and retrieval. SANs provide high reliable and fault-tolerant storage. SANs are typically have multiple power supplies, and SANs will typically have duplicate network connections. SANs typically use a redundant array of independent disks to provide redundancy and high performance. SANs often use spare drives where it can automatically swap out a failed drive with one of the spare drives. RAID will automatically be rebuilt when a spare drive is added. SANs are ideal for virtual environments that run multiple physical hosts that run many virtual machines. If the virtual machine supports it, if a physical host fails or gets disconnected, the virtual machines that run from the SAN can switch from one physical host to another physical host automatically. You need to make sure that you have enough processing power and memory on the remaining hosts that can run all virtual machines if one of the hosts failed. Now, putting it all together, here's the same SAN infrastructure that we have been seeing. As far as the servers are concerned, they see the disk from the storage area network as local disks on the servers. However, the NAS has been added to the server network where users will access the file on the NAS via Universal Naming Convention, or UNC, that follows the \\server name \share name format, which is based on the server message block or SMB protocol. Question: what device acts as a file server? Answer: NAS. Question: what type of storage does a NAS provide? Answer: file. Question: what type of storage does a SAN provide? Answer: block. Question: what type of interface would you use with a SAN that is the most cost effective? Answer: iSCSI. Question: what network would connect to a NAS to? Answer: your local area network. Question: which of the protocols can be routed? Answer: iSCSI. Because it's built on IP, it can be routed across different subnets or networks. Question: which of the following is most likely to work with an FC connection and offers more scalability? Answer: SAN. For more information, refer to these sites. In summary, a network attached storage, or NAS, is a file storage device that connects to a network, allowing multiple users and heterogeneous client devices to retrieve data from a centralized disk capacity. Basically, a NAS is a file server. A storage area network, or SAN, is a high-speed network that connects and provides shared access to consolidated pools of storage devices. A storage area network, or SAN, uses specialized switches designed to handle high-speed data traffic between storage devices and servers. The SAN switches use either fiber channel or FC switches or iSCSI switches. Thank you for watching this video. This completes the basic networking hardware series. The next series will be wired networking. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.